This is SpaceTime Series 25, Episode 17, for broadcast on the 9th of February 2022. Coming up on SpaceTime, discovery of a new Earth Trojan asteroid, hundreds of mysterious filaments discovered floating in the heart of the Milky Way, and China launches more Earth observation satellites. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a new Earth Trojan asteroid. The finding, reported in the journal Nature Communications, indicates the asteroid, catalogued as 2020 XL5, is about 1.2 kilometres wide and was detected in the Lagrangian L4 position, a gravitational well located 60 degrees ahead of Earth's orbit around the Sun. Calculations suggest that this new Trojan will remain in that position for at least the next 4,000 years. It's only the second Earth Trojan asteroid to be discovered. The other, 2010 TK7, was only 300 metres in diameter and was discovered by NASA's Wide Field Infrared Survey Explorer spacecraft in 2010, also in the L4. Trojans don't orbit right at Lagrangian points, but rather oscillate in tadpole-shaped loops around them, at least as viewed from a co-rotating reference frame in which the planet and the Lagrangian points are stationary. Trojan asteroids have long been detected in other planetary systems, such as Venus, Mars, Jupiter, Uranus and Neptune. In fact, NASA has a mission going to the Jovian Trojans right now. But finding Trojans around Earth's always been difficult because of the glare of the Sun, which always obscures them from clear view. Astronomers have developed numerous observational strategies to try and detect new Earth Trojans, including in situ surveys such as a search within the L4 region carried out by NASA's OSIRIS-REx spacecraft, and a search within the L5 region conducted by the Japanese Hayabusa 2 mission. But dedicated efforts have for the most part failed so far. The problem is the observational time window between the asteroid rising above the horizon and the sunrise is usually very small. Therefore, astronomers need to point their telescopes really low in the sky where visibility conditions are at their worst, and they've got the added handicap of the imminent sunlight saturating the background light, meaning they've really only got just a few moments of observational time. Still, the authors in this study managed to make their discovery using the 4.3 meter Lowell telescope in Arizona and the 4.1 SWORD telescope in Chile. The study's lead author, Toni Santarose from the University of Barcelona, says the Earth Trojans hold a pristine record of the early conditions during the formation of the solar system, since they might have been co-rotating with the planet during its formation. Earth Trojans would also be ideal candidates for potential space missions. Because the Lagrangian L4 position shares the same orbit as the Earth, it would be relatively easy to reach. Santarose says Earth Trojans could also become ideal bases for an advanced exploration of the solar system, and they could even become a source of resources. This is SpaceTime. Still to come, hundreds of mysterious filaments discovered floating in the Milky Way's heart, and China launches its 156th Earth observation satellite. All that and more still to come on SpaceTime. Astronomers looking at the turbulent centre of our Milky Way galaxy have observed nearly 1,000 mysterious strands or filaments which seem to be simply dangling there in space. The unprecedented new observations reported in the astrophysical journal Letters were captured by South Africa's MeerKAT radio telescope array. Stretching up to 150 light years long, these single-dimensional strands are found in pairs and clusters, often stacked equally spaced side by side, like strings on a harp. The mystifying filaments are composed of cosmic ray electrons gyrating in a magnetic field at close to the speed of light. The strands were first observed way back in the 1980s, but the mystery of their origin has never been resolved. Now the new MeerKAT observations are showing there are at least 10 times more filaments there than previously discovered. And this has allowed scientists to undertake the first broad-based statistical studies of the filament population, finding information which could potentially ultimately help to unravel their mystery. The new data has required 3 years of research, painstakingly piecing together a detailed mosaic of 20 separate observations taken over 200 hours, looking at different sections of the sky towards the center of the Milky Way galaxy, some 27,000 light-years from Earth. Along with the filaments, the observations also captured radio emissions from numerous phenomena, including outbursting stars, stellar nurseries, and new supernova remnants. To view the filaments in finer details, scientists used a technique to remove background from the main image in order to isolate the filaments from the surrounding structures. Astronomers focused on the filaments' magnetic fields and the role that cosmic rays play in illuminating these fields. The variation in radiation emitting from the filaments is different from what would be emitted from, say, a supernova remnant, and that suggests the phenomena must have a different origin. While scientists already knew that the filaments were magnetized, the new data has shown that the magnetic fields are actually amplified along the filaments, a primary characteristic which all these filaments share. Among the remaining mysteries astronomers are yet to resolve is how structured these filaments appear. The filaments within the clusters are separated from one another at perfectly equal distances, about the same distance as from the Earth to the Sun. In fact, they resemble the regular spacing seen in solar loops. And scientists still don't know why they come in clusters, or understand how they separate and why they retain regular separation spacings. Other mysteries include questions over whether the filaments move or change over time, and what's causing the electrons in them to accelerate so close to the speed of light. Astronomers are now working to identify and catalogue each filament, including its angle, curve, magnetic field, spectrum, and intensity. Understanding these properties will give scientists more clues into the filament's elusive nature. This is SpaceTime. Still to come. China launches its 156th Earth observation satellite, and NASA's Greenland glacier study. All that and more still to come on SpaceTime. Okay, let's take a break from our show now for a word from our sponsor, NordVPN. You know, these days people need to take extra care about what's happening online. They need to be concerned about their online privacy and security. And that is where NordVPN comes in. It helps to protect you and your family from online threats, keeping your identity and data safe and secure. NordVPN encrypts all your traffic so no one can see what you're doing online. Creepy prying eyes don't get a look in. And they have a strict no-logs policy, so you can be sure that your data cannot be shared or accessed by others. With NordVPN, you can connect to any of their 5,200 plus servers in 60 countries, so you can access more content from around the world. And NordVPN has amazing speed. Tests confirm it's rated as the fastest VPN out there, and that means you won't have to wait long for videos and websites to load. You'll be able to surf the web and stream movies with ease. Plus, I found NordVPN to be really easy to use. So, you really do need NordVPN to take care of your online security, and that's why I want you to do what we do and give NordVPN a try. And this is where our exclusive offer for SpaceTime listeners comes in. Just go to nordvpn.com/StuartGary or use our special code StuartGary and you'll get a huge discount off your NordVPN plan, plus one additional month for free and a bonus gift. And of course, there's NordVPN's 30-day money-back guarantee. So what have you got to lose? Grab your exclusive NordVPN deal by going to nordvpn.com/StuartGary or use the code StuartGary to get a huge discount off your NordVPN plan, plus one additional month for free and a bonus gift. That's NordVPN. Give it a try. And of course, we'll include the link details in our show notes and on our website. And now, it's back to our show.
This is SpaceTime with Stuart Gary.
China is continuing its program of launching vast numbers of Earth observation satellites. The latest is the LSAR-01A, which was launched aboard a Long March 4C rocket from the Jiuquan Satellite Launch Center in northwestern China. The 3.2-ton spacecraft was placed into a 607-kilometre high sun-synchronous orbit. The satellite is equipped with an L-band and multi-channel synthetic aperture radar, allowing it to penetrate clouds, rain and vegetation. Its sister satellite, the LSAR-01B, is slated for launch later this month. China now has some 449 satellites orbiting the Earth. And since 2016, Beijing has launched more than 156 Earth observation, surveillance or reconnaissance satellites designed to provide near-continuous high-resolution and electronic monitoring of areas of interest to China. This is SpaceTime. Still to come, NASA's revolutionary new Greenland glacier study. And later in the science report, it appears there's no escape for the world's coral reefs as global warming continues to worsen. All that and more still to come on SpaceTime. A new study has confirmed that warming ocean waters are melting Greenland's glaciers from below at least as much as warm air is melting them from above. The findings, which have revolutionized science's understanding of the pace of sea level rise, are based on NASA's 6-year Oceans Melting Greenland mission, which surveyed the giant island's coastline. The study confirms that ice loss from Greenland's ice sheet is contributing more to global sea level rise than any other single source on the planet. The authors found that Greenland's glaciers are now melting up to 7 times faster than what they were 25 years ago. The problem is, if all of Greenland's ice sheets melt, global sea level rise would be about 7.5 meters. That's 24 feet. The Oceans Melting Greenland mission undertook the most complete survey ever carried out on the seafloor around Greenland's coastline. It included the first scientific measurements along some of the most remote coastlines in the world, and included dozens of previously uncharted fjords which are clogged with icebergs from disintegrating glaciers. More than 220 glaciers flow from Greenland into the ocean. Scientists always knew that ocean water swirling around and under these glaciers had to be contributing to their ice loss, but they had no real idea how much. The problem is satellite observations of sea surface temperatures can't answer that question. Around Greenland, the top layer of the ocean is extremely cold and not very salty because it contains a lot of water from the Arctic, which is the freshest of all the oceans. Now, a shallow glacier that only touches this layer of water would melt slowly. However, hundreds of meters further down, the ocean's a lot warmer because it's saltier. And a deep-seated glacier would be eaten away more quickly by this warmer water, losing ice 4 to 5 times as fast as a shallow one. The only way to find out any glacier's risk is to measure the glacier and the seafloor and the water in front of it. Now, scientists have been doing this by studying individual glaciers for many years. But Oceans Melting Greenland principal investigator Josh Willis from NASA's Jet Propulsion Laboratory in Pasadena, California, wanted to measure all 220-plus glaciers in order to get the most complete picture possible. Scientists drop some 250 probes a year in order to measure ocean temperature and salinity right down to the seafloor at strategic locations right along the entire Greenland coastline. The data shows that up to 4 times as many glaciers are sitting in the warmer water than previously thought, and so have a far higher risk of melting. Willis also says that around a third of all Greenland's glaciers account for about half of the ice loss, and all of those are sitting in warm water.
We've been watching Greenland melt for 25 or 30 years now, and you can see the surface melt every year from satellite data. We know the weather pretty well. We know when it gets warm enough to melt the ice. But looking at the glaciers around the edges, these fast-moving rivers of ice that dump ice into the ocean, it started to become clear oceans could actually play a role in controlling those glaciers. And so Oceans Melting Greenland, or OMG for short, was born as a way to try and answer the question, how much are the oceans controlling the glaciers? How much are they causing them to dump extra ice? And what does this mean for the future of the ice sheet? Greenland has enough ice to raise sea levels by 25 feet if it all melted today. The ice sheet is 10,000 feet tall in the middle, and you fly over it in a jet for 2 hours and you're still on top of it. So It's an enormous chunk of ice and something that is a big part of our climate system.
So by 8 o'clock, we'll figure out if we're going to go north. If we don't go north today, then we have to hit it hard Wednesday to go north and then leave for Thule on Thursday because the weather is not looking good.
It's always an adventure doing work in Greenland, and it never works out exactly like you planned it. You really have to pick your places very carefully where you're going to be able to land, stay a couple of nights, get fuel for the airplane. And of course, the schedule almost immediately gets thrown out the window because the weather's bad or, one of 100 other things could go wrong. And the last 2 years, we also had to deal with COVID. It was just one more of 100 other challenges of getting this crew and this airplane to measure the ocean temperatures really all along Greenland's coastline once a year for 6 years. We started with a ship. The ship drove around the edges of Greenland and mapped the sea floor. The water there, remember, is upside down. You've got the cold water at the top and the warm water down below. So if the warm water is going to reach the glaciers and interact with them, the glaciers have to be sitting in warm water, and there has to be some deep water that connects the glacier with the water offshore. So the first couple of years, we really just mapped the seafloor, and we revolutionized our knowledge of the seafloor depth around the island. Huge areas had just never been mapped, and we had no idea how deep they were. So with the data collected by OMG, we now know not just which glaciers are reacting to the ocean, but why they're reacting. And it's almost always because they're sitting in deep water, and there's a deep channel connecting them to the offshore. When we were flying around measuring the oceans, you drop this cylinder out of the airplane. It falls on a little parachute, and when it hits the water, it separates into two parts, and one part stays at the surface, and it radios data back to the plane, and another part sinks, and we get one profile of the temperature and the saltiness of the ocean from the surface all the way down to the seafloor, because we really want to know what that deep water is doing, because that's the water that melts the glaciers. We drop those things about 200 times a year, covering the entire area around Greenland, so we have a snapshot of what the oceans look like. What we've shown during the course of OMG is that the glaciers are paying a lot of attention to the oceans. These are magnificent, enormous rivers of ice that empty into the seawater, but they're not disconnected from what's happening in the oceans. When the oceans warm, they retreat more quickly. When they cool, sometimes they even grow. And these glaciers are often sitting in a lot deeper water than we've realized previously. And that means they're a lot more threatened by the water. And Greenland has the potential to raise sea levels much higher than we previously knew. So basically, every time we made a big discovery on OMG, we had to raise the bar on our predictions of sea level rise from Greenland. Without the ocean's role in melting away the ice, you're only getting half the story. I started working on OMG in 2012, almost 10 years of my life, and I've definitely grown as a scientist. I started with one idea of Greenland as a pretty simple block of ice. Of course, it's fantastically complicated and interesting. You see these sharp mountain ridges where the ice has just cut a channel right through it. There's giant icebergs. The glaciers are literally moving, so you can't see them with your naked eye, but if you go back from one year to the next, you can see how they've changed. It's really a dynamic place, and that's part of the reason it's so scientifically interesting, but of course, it's just beautiful to look at, too. If you talk to Greenlandic folks who have been living near these glaciers and whose families have been watching these glaciers for generations, they know that the glaciers are shrinking. We found that they wanted to know about the science and what we were finding almost as much as we did. They're living in a landscape that's changing probably more dramatically than anywhere else on Earth. This is an important place. It's important for the entire world. As ice is lost in Greenland, sea level goes up everywhere. It's literally all around the planet is affected by what happens in Greenland, and so it's going to shape a lot of our future too, not just the Greenlandic folks.
That's Josh Willis from NASA's Jet Propulsion Laboratory in Pasadena, California. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that if and when global warming reaches an increase of 1.5 degrees Celsius, almost all the world's coral reefs will feel the effect of the hotter ocean temperatures. Currently, about 84% of the world's coral reefs are in locations where local ocean dynamics, things like upwelling and strong currents, are sheltering them from the dangers that warmer ocean temperatures pose. The new study, reported in the journal PLOS Climate, used the most up-to-date climate projections and satellite data to monitor the impact 1.5-degree warming would have on these safe havens. Scientists found that should the world reach that threshold of 1.5 degrees Celsius, almost all current coral reefs would be impacted, with just 0.2% still protected in these refuges. A new study has found that males are twice as likely as females to fall victim to online extortionists, threatening to publish explicit photos, videos, and information about them, with young people, Black and Native American women, and LGBTIQ individuals also at high risk. The findings, reported in the journal Victims and Offenders, is based on a survey of over 2,000 people across the United States. The study found the perpetrator can be a current or former partner, a complete stranger who's hacked into a person's photos or webcam, or an online dating scammer. Researchers asked 2,006 people if they've ever been a victim of sextortion, which is defined as the act of threatening to expose a nude or sexually explicit image in order to get a person to do something, such as send more nude or sexually explicit images, pay money, or perform sexual acts. Researchers found that 4.5% of men and 2.3% of women said they'd experienced sextortion since the start of the pandemic. Black and Native American women were around 7 times more likely to be victims of sextortion than white women, and rates in the LGBTIQ community were also some 3 times higher than that in the heterosexual community. Age was also a factor, with the highest being among the 18 to 29-year-olds, which might be due to greater sexual experimentation and more use of technology in this age group. A new study warns that young people with eating disorders may also have an underlying and undiagnosed autism spectrum disorder. A report in the journal Advances in Neurodevelopmental Disorders by scientists at Flinders University examined more than 100 autistic and neurotypical young people, finding those on the spectrum were more likely to experience autism-focused eating behavior disorders alongside rather than instead of typical eating disorder behaviors. The authors say health practitioners need to be mindful that these conditions can co-occur, and they need to consider both diagnoses prior to commencing treatment. The findings come as a second autism study has discovered that young kids who experience too much screen time as toddlers were 0.4 times more likely to be diagnosed with autism. The study, involving 84,000 kids in Japan over 3 years, found that boys were 3 times more likely than girls to be diagnosed with autism. Now, researchers stress the additional screen time didn't cause the autism, but more likely kids with autism tended to want more screen time. Apple are about to introduce a new update for the iOS operating system. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
iOS 15.4 will have a big feature, a long requested feature, which is the ability to unlock using Face ID whilst you're wearing a mask.
That's very
what
timely.
it's doing, yeah. Well, in some instances, it's probably a couple of years too late, but we never knew how long this pandemic was going to last. And Apple did launch with iOS 14.5 the ability to unlock your iPhone if you're wearing an Apple Watch. But not everybody has an Apple Watch with their iPhone. And because mask mandates seem to come and go, having to wear a mask does cause problems for Face ID. But what Apple is doing is they're using features around the eyes, and they're using the eyes to identify you. Obviously, it's not going to be as secure as not wearing a mask, and there's also an option to be able to add glasses. I mean, already the Apple Face ID can detect whether you've got glasses or sunglasses on or not, and you can even add a second Face ID face of yours. I mean, you might be having a beard, or you might be having different hairstyles or different sorts of glasses, so you can already program a second face into the Face ID. if you look sort of quite different, or if you wanted, I guess, even somebody else to be able to open your iPhone like a partner. But the ability to have the masking with Face ID is going to be a big thing when it comes out in iOS 15.4, which will probably be in a couple of months. It's already in beta. Normally these things go for a month or two before they're launched. So that will be a very exciting feature when it comes out.
How sophisticated are facial recognition programs nowadays?
Well, on the iPhone, it's very sophisticated. They're using 15 or 30,000, I can't remember which, infrared dots to identify different parts of the face. And other companies have tried doing similar things. Huawei had something similar, but at the time there were people who said they could fool it. There were different facial ID systems that just basically looked at your face sort of as a 2D image rather than a 3D image. I remember I had a Samsung Galaxy Note 10, I think it was, maybe a Note 9. And at the time, you could use a photograph. I mean, they fixed it later on. They made it harder to break. But for a while, you could. I was using a picture of myself on one phone to unlock my other phone, and that's obviously not good. So that's one reason why I think Google doesn't have Face Unlock on its Pixel 6 and 6 Pro. You have to use fingerprint ID or a code. So Face ID is not there at all, even though that was something they did with, I think, LiDAR sort of technology with the Pixel 5. They launched it. Again, at the time, there was the issue where you could have your eyes closed and your face could unlock the Pixel phone of that era, which was bad because your kids, for example, could grab the phone and unlock it whilst you were asleep, something that kids were doing with fingerprints. There were famous instances where kids were unlocking phones and... there was a famous instance where a lady was on a plane and her husband was asleep and she unlocked his phone using a thumbprint and saw these messages from a mistress of some sort and got very upset and was causing a scene on the plane. And with Face ID, you can actually have it so that you must be paying attention. Your eyes must be looking at the sensor. That way it makes sure that you really are unlocking the phone on purpose. Although I guess if you're kidnapped and they're holding the phone to your face and forcing you to unlock it that way, the Face ID is not going to be in that much of a protection. But that would be the case. I mean, I remember when in James Bond movies when they needed fingerprints or thumbprints and they were just cutting people's hands off or fingers off and putting them onto the unlock device. So look, I mean, I do remember there was a warning with Face ID that if you had a twin or you had another family member who looked very, very similar to you, there was the possibility of them unlocking it. So it's not entirely foolproof, but it's still safer than fingerprints, and it's very convenient.
That's Alex Zaharov-Reut from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.